Hi, I'm Jason Link, Product Manager for LC Columns at Agilent, and I'm here with Rory Doyle, who works in our Center of Excellence here in Wilmington, Delaware. We're sharing a full workflow solution with you, demonstrating protein precipitation and analysis, specifically looking at a pain management drug screen. In Part 1, we showed the sample preparation, in this case, a simple filtration using Captiva ND Lipids well plates, which helped remove lipids that would have potentially suppressed the MS signal.
So we're ready now with our analysis of the sample. This analysis is similar to the one that a clinical lab might do for therapeutic drug monitoring, or to monitor for possible abuse of some pain management drugs. This sample contains hydrocodone, oxycodone, and codeine, opiates that are amphoteric, water-soluble, so they will elute in a higher aqueous mobile phase or early in a gradient separation. If we look at the chromatogram of a more comprehensive drug panel, you can see the range from polar to nonpolar analytes, and our group is here in the front, early in the gradient separation. We're going to be running our samples on a 1290 Infinity LC system, as shown here, connected to an Agilent 6490 triple quadrupole mass spectrometer with iFunnel technology here. The new iFunnel technology increases the number of ions entering the mass spec, increasing both sensitivity and specificity. The ion funnel is made up of a hexabore capillary sampling array in line with two offset ion funnels. This setup allows more ions to enter, be focused, and separated from any background material, improving both sensitivity and specificity.
Like everyone these days, we're interested in getting our analysis time to be as short as possible without sacrificing data quality. Let's talk about why we've chosen a Poroshell 120 column for this analysis. We're using Poroshell 120 for a few key reasons. First, it enables us to get high efficiency for our analysis, producing a nice sharp peak, which is helpful for improving the sensitivity in the MS analysis. It's also a great column choice for productivity. That is, we can use higher flow rates and shorter columns to speed up our analysis time and increase throughput.
The other key reason is that the Poroshell 120 columns are rugged. They have a standard 2-micron frit, which is more forgiving for difficult samples like plasma. So you'll extend your column life versus columns with smaller frit porosities, such as sub 2-micron columns with a column that can work on an LC or HPLC.
We've chosen a Poroshell 120 EC-C18 or NCAP C18 for this analysis. The C18 is an excellent first choice column for method development due to its versatility and performance with a wide range of analytes. Also, the end capping on the EC-C18 will help ensure the best peak shape for our analysis.
What length of column are you using?
We'll look first at the method run on a 2.1 by 100 millimeter column. Generally, a longer column length will give us more sensitivity and more resolution, and the narrow diameter is good for the mass spectrometry, resulting in better separation and increased performance. This improves the signal to noise, limits of detection, and quantitation, as well as the overall performance. Okay, before we get started, we need to assess our instrument setup to ensure it's optimized for a high efficiency column like the Poroshell 120. We're working today with an Agilent 1290 Infinity LC system. The maximum operating pressure of this instrument is 1200 bar, or about 17,000 psi. First, we'll check out the tubing and ensure it's as short as possible. We want to make sure to minimize any extra column dead volume in the system, so we want to be sure we don't have any pieces that are too long. And ideally, we should be using the 120 micron ID red tubing, as you see here. Agilent has also recently introduced 75 micron tubing for cases requiring the least amount of dead volume possible. In this case, I think the 120 micron tubing will be sufficient.
Next, we want to make sure our detector response time is set correctly. Here, the scan speed of the mass spectrometer must be fast enough to acquire an adequate number of data points to define the narrow peaks generated using a fast LC column like Poroshell 120. The tighter the scan speed, the better, so you get sharper peaks and increased sensitivity. Our default setting is 100 milliseconds, and that will work well for this analysis with Poroshell 120. Generally, for reproducible quantitation, you want 15 to 20 data points across the narrowest peak. If you're using a UV detector, you'd want to change your detection rate in ChemStation. The peak width control in the ChemStation enables you to select the peak width or response time for your analysis.
For the LC, if you were using UV detection, you'd also want to be sure your flow cell is a smaller volume flow cell. Agilent has introduced a new ultra-low dispersion flow cell called the Agilent Ultra-Low Dispersion Max Light Cartridge Flow Cell, which is recommended for the 1290 Infinity LC diode array detector. Older instruments may have a larger volume flow cell, which can affect your results, so it's good to check.
As an aside, if you are using the mass spec, you should not be running the DAD unless it is absolutely necessary. Otherwise, it will create extra column volume, because you'll be running your sample through extra tubing, which increases the volume. Keeping the DAD in series prior to the MS will broaden your peaks, thus reducing Poroshell 120's high efficiency.
Now, we're going to do our analysis of the sample we've prepared to determine the concentration of our analytes. Let's talk about solvent selection. For mass spec, we have some special considerations.
That's right, Jason. Some of the typical solvents you'd use for UV are not appropriate for mass spec. It's important to exclude non-volatile materials from the mobile phase, and even the sample in some cases, to prevent fouling of the ionization source as the mobile phase is nebulized and partially dried in the source. Today we see universal trends towards formate and acetate and other volatile ammonium salts as mobile phase additives.
For this analysis, we'll use 5 millimolar of ammonium formate for solvent A with 0.01% formic acid. This will give us better resolution and peak shape for these analytes. We have acetonitrile with 0.01% formic acid in our B bottle. Generally, we select our mobile phase and modifiers to get the best retention and selectivity with our analytes with MS compatibility. In this case, we've chosen the ammonium formate and the formic acid as an all-around choice for initial development of our method. We strongly recommend you put the formic acid in both bottles because when each solvent is on the column remains equilibrated with the formic acid. You also control the pH in both bottles this way.
The flow rate we'll start with is 0.5 mils per minute. With these small particle, high efficiency columns, we get maximum efficiency at a higher flow rate than we would normally use with conventional columns. So this is a starting flow rate that is appropriate for the Poroshell 120 column. No efficiency is lost at the higher flow rate because these particles give us better mass transfer and lower eddy diffusion. The 6490 triple quad can handle flow rates up to 1 mil per minute. You would not want to go any higher than 1 mil per minute unless the instrument is fitted with a jet stream ion source. The jet stream allows you to have a higher flow by increasing the flow of solvent into the ion source, allowing the sample to be efficiently ionized, and in the process, cleaning out any extraneous material that might be in the sample. The jet stream is standard on the 6490 MS system, but if you have an older model, you can order it as an accessory. If you don't have any jet stream, too much flow results in a lack of ionization of the sample and reduces MS sensitivity.
Just a couple other parameters to mention. Our column is thermostated to 25 degrees Celsius. It's good practice to thermostat the column for maximum method reproducibility. That way, the results are the same regardless of the room or lab's temperature.
You know, Jason, it's nice to have the same results regardless of whether it's winter or summertime.
Yes, it is, Rory. Now, before we move on, I'd like to point something out. As more and more chromatographers are working with noxious or volatile solvents, safety in the lab is an important concern. These bottles are fitted with Agilent solvent safety caps, which prevent leakage of solvent vapors into the air and improve lab safety. They also reduce evaporation of volatile solvents, reducing problems with retention shifts that may occur when solvent or modifier concentrations change due to evaporation.
And anything that preserves solvent use saves money too.
It certainly does.
Okay, so on screen I'll show you our chromatogram. We've already input our method into the Mass Hunter software and run our analysis. This method uses a gradient which allows for a faster, more efficient method, especially with many compounds. Here we're only analyzing 3 compounds. If you were doing analysis for a large number of analytes, for example, analytes which differ widely in polarity or molecular weight, the gradient becomes even more important. So Jason, how can we save time here?
We could use a 2.1 by 50 millimeter column, but we'll lose a little bit of resolution. Given that we have good resolution with the longer column, migrating to a shorter column would be a good way to evaluate whether we can shorten our method and still get good results.
That's right, Jason. A couple more points about shorter columns. Combined with the narrow bore columns, it's a very effective way to save money on solvent costs. And by using the shorter column, you can increase your productivity and your lab throughput.
Yes, good points, Rory. Now, for the shorter column, we need to adjust our gradient. In general, we want to keep our gradient slope the same so the relative elution order remains the same. One helpful tool for adjusting methods like this is to use the LC method translation tool, which lets you input your starting method parameters and will calculate the new method for you based on your desired new column choice. You can find that tool at the URL listed on the screen. As you can see, the shorter column cuts our analysis time nearly in half, and the resolution looks very similar.
Good to see. So let's move on to the mass spec. We're working with the Agilent 6490 mass spectrometer with iFunnel technology. This is Agilent's newest instrument for bioanalysis and quantitation, like what we're doing today. The 6490 is a new system that has a 25% smaller footprint with a sensitivity specification that is 10 times higher than previous MS models. It contains an iFunnel technology that relies on Agilent Jetstream technology thermal gradient focusing to create a high abundance of accessible gas phase ions. These ions are then drawn into the mass spectrometer through a hexabore capillary sampling array, 6 parallel capillaries that accept nearly 12 times more ion-rich atmospheric gas than previous systems. The ions are focused and separated from the gas by a dual ion funnel assembly. The first high-pressure funnel removes most of the gas and focuses the ions into the second low-pressure funnel, which removes the remainder of the gas so the ions can enter the Q1 optics. The 6490 also has a new curved tapered collision cell that allows a compact system design and reduces noise to help improve overall sensitivity and extends the ability of the instrument to detect molecules at the zeptomole, 10 to the 21 mole level. The iFunnel technology also enables an unprecedented linear dynamic range that extends to 6 orders of magnitude for many compounds. Because the MS is so sensitive and selective, it doesn't require much sample prep. Let's talk about ion suppression and what it can do to the MS results. Ion suppression is a type of matrix effect when there are compounds in the sample that inhibit response. See on screen some examples of the post-column infusion studies for lipids. See at the top here what the lipid profile would look like with a typical protein precipitation method, such as our regular Captiva ND plates. These lipids will stick on the column for up to 50 column volumes and build up in the system to cause clogs. This can also contaminate the mass spec. See in orange below it the profile of SPE, which is a more time-consuming and expensive sample prep method that may be overkill for this analysis. The third one down shows liquid-liquid extraction, which can be good but uses a solvent that is hydrophobic, so we will see some lipids that aren't retained. The last example shows our Captiva ND Lipids results. This is a great solution when you have analysis that have low log P values below 3. It's important to remove lipids, proteins, and other components that cause interferences that can create ion suppression. These can contaminate the ion source and result in required maintenance too. A simple filtration, like the one we did before this analysis, will remove the lipids and get us the good results we have seen. So we've seen our chromatogram from our separation, and now we can look at the spectral data for each of our compounds. We're going to use our Mass Hunter software here. We can look here at the transition parameters of the 3 compounds we've screened.
Our analysis is complete, and our total time for this method, including sample prep, is just a few minutes. The Poroshell 120 column is an excellent choice for bioanalytical applications involving samples like blood, urine, and plasma, because its 2-micron frit makes it more forgiving and less likely to clog.
That said, it's helpful to do just enough sample prep. In this case, a simple filtration that takes only a minute or 2. That will further protect your system and your mass spec from materials you don't want in your analysis, and it helps reduce ion suppression, in this instance by removing the lipids from our sample.
If you've been using conventional columns, you'll want to make a few adjustments to your instrument, reducing extra column volume and checking the scan rate of your detector before you begin.
The Agilent 1290 Infinity LC and 6490 triple quadrupole MS system, together with Captiva ND Lipids and Poroshell 120, have delivered excellent resolution of our matrix components and improved analyte sensitivity in less time.
Thanks for watching, and as always, contact Agilent Tech Support if you have any questions. You can find your local tech support on agilent.com. Thank you.